In this lesson, you will learn about imaginary and complex numbers. By definition, an imaginary number is the square root of -1. We use an I in math to represent an imaginary number. You also need to know that I squared equals -1. We can show that by taking I equals the square root of -1 and squaring both sides. Squaring and square root are opposite operations, so those cancel one another out, a lot like addition and subtraction, multiplication and division are all opposites. So I squared equals -1. We'll use this later in other lessons, but I is the square root of -1 and I squared is -1. Let's look at some examples when we're simplifying. So we have the square root of -13. You should have previously learned how to simplify radicals. For example, just the square root of 13. But now that we're simplifying the square root of -13, you can look at this as the square root of -1 times 13. Well, the square root of -1 is I, and the square root of 13 is a prime number, so it will stay as the square root of 13. So this is going to become I, the square root of 13. Let's look at our next example, number 2. The square root of -144. So again, we can rewrite this as -1 times 144. You should know that 144 is a perfect square, or you can do your prime factorization. So the prime factors of 144, we'll start with dividing by 2. 2 goes into 144 72 times, and divide by 2. 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 2 will not work, so we'll have to go with a different prime. We have 3. And then 3 divided by 3 is 1. So because we're doing square roots, we're going to be looking for pairs of like factors, because remember, understood index number is a 2. So we have a pair of 2's, another pair of 2's, and a pair of 3's. So for each pair, that's what we would bring outside the radical. So we have 2 times 2, which is 4, and 4 times 3, which is 12. So again, 144 is a perfect square, so if you didn't know that, you could always do your prime factorization. But the square root of 144 is 12. Because we're taking the square root of a -144, we would actually write it as 12i. Notice whenever the imaginary number comes outside the radical, we would write it in front of the radical sign. If there's no longer any radical, of course, it goes after the 12, which would be our coefficient. We would not want to put the I after the square root of 13 because we could confuse it with being inside the radical. So this is the proper way to write our imaginary numbers. Let's look at another example, number 3. We have the square root of -18. So again, if you'd like, rewrite that as -1 times 18. We know the square root of -1 is I, so now we just have to find the square root of 18. We are going to simplify it by using our prime factorization. So go off to the side. 18 can be divided by 2, gives us a 9. 9 is divided by 3, which gives us a 3. And 3 is divided by 3, which is a 1. So we have a pair of 3's. Again, we're looking for pairs because we're doing square roots. So we have the I that's going to come out of the radical. We have a 3 that's going to come out of the radical, and the 2 that will stay inside the radical. So the simplest way to write this answer is 3i, the square root of 2. Let's talk about complex numbers. A complex number is a number in the form of a plus bi, where a and b are real numbers and the I is the square root of -1. So complex numbers, a plus bi, a is a real number and the b is a real number with the imaginary. The a is the real part and the bi is the imaginary part. You must write your complex numbers in this form, a plus bi. So let's look at some examples of what will be and what would not be a complex number. A complex number could be 3 plus 4i. You could also write the complex number 4 minus 2i. Although that doesn't say plus bi, you can make it plus a -2i, and it is a complex number. Another one that would be a complex number, 1 minus I, the square root of 5. Just like we talked about earlier with example 1, in order to write your bi, because we have a radical, we would put the I in front of that, so this does result in a complex number. A is the 1 plus, you can make that plus a negative. This is your bi term. Even though it is a radical, it's still a complex number. Some examples of things that are not complex numbers. Maybe, for example, 4i plus 7i. That can be combined, 4i plus 7i, and make one term. But that is not in the form of a complex number because it does not have the a plus bi. Another example of something that's not a complex number, if we do 9 minus 7. 9 minus 7, you can simplify and combine those together, but it's not going to be a complex number because once again it's not in the form a plus bi.